Hey folks, welcome to a little video on graphing piecewise functions. I'm going to take you through a few examples here and even give you a little opportunity to try to graph these on your own. This is a particularly difficult unit that we do each year along with absolute value and analysis, and so I thought I would take a second and really give you a little bit more practice and some examples on how this works. So I'm going to show you a few different piecewise functions. One of them is going to have 2 pieces, 2 of them will have 3 pieces, and one of them is even going to have 4 pieces. Now, as I go through each of them, I'm going to show you some things you might want to know, including some pretty common questions that I get when I do these kinds of problems. Okay, so in my first graph, I'm going to do this function right here. F of x equals -2 if x is less than or equal to 0, and it equals 2x minus 3 if x is greater than 0, okay? So I'm going to go one piece at a time. Now, my first piece right here, right, -2 is what I'm going to graph first. You always go from your lowest values of x to your highest values of x. Now, notice that this doesn't have an x next to it. Okay, that means that no matter what x is, the output is going to be equal to -2, right? Which means that it's going to be represented by a horizontal line. Now remember, when we graph these, what do we do first? Remember, we graph the whole line. Okay. Then what we're going to go ahead and do is we're going to erase everything except where x is less than or equal to 0, not y. That's one of the big mistakes people make. So here I go, and I apologize in advance if my camera starts to get a little bit shaky, because I'm so excited to do this that sometimes it makes my camera shake. Okay, so hopefully there wasn't too much shaking in there. So I've gone ahead and erased everywhere x is not less than or equal to 0. Okay, that is where x is more than 0. Now I'm going to come to the end, and in this case, remember, we use a closed dot. And the reason that is because since x is less than or equal to 0, because of the or equal to, 0 actually is included in this piece of the diagram. And remember the Sophia H rule. More ink to do the or equal, more ink to fill in the dot. Okay? For my second piece of the function, I'm going to do the graph 2x minus 3. Okay? Note that that is a linear function. It's in y equals mx plus b form, and b is equal to -3, and m is equal to 2. Okay, so it's got an intercept of -3 and a slope of 2. Okay, so here I go. I'm going to graph the whole line, and then what I'm going to do is I'm going to connect that line. Okay, and in class you would have a ruler to do that, so that would turn out a little bit nicer. You can already see that this thing is not going to pass the vertical line test. And remember, the vertical line test is the test that says if I run a vertical line up and down, it should only touch the graph at most 1 point. Okay, but observe how I only want the piece of the graph where x is more than 0, so I'm going to erase everywhere where x is less than 0. And again, I apologize if things start to get a little shaky for a second. Ooh, there goes my function. And now on the dot, I put an open circle because this is strictly more than 0, not equal to 0. And voila, I have my function. So this is the function that contains the pieces -2 and 2x minus 3. Notice how, again, if I pass my line straight up and down, it's only not continuous at x equals 0. This is what we call a discontinuity, because when x equals 0, I've got to pick up my pen and start at this point right here, okay? So I have the graph of -2 and 2x minus 3. Okay? So if you need a second to take another, kind of look through this, go ahead and pause the video and rewind. Otherwise, I'm going to move ahead to the next function. All right, so we'll send that little guy away, and here we go. I've got a brand new function here. F of x equals 2x plus 7 when x is less than or equal to -2. negative 1/2 x plus 4 when x is greater than negative 2 and less than positive 2, and negative x when x is greater than or equal to 2. Okay, so I'm going to go ahead and do the same thing. I'm going to graph one piece at a time, and I'm going to start with the first piece and make my way down. So this one is again a line, and I'm going to start with an intercept of 7, and I'm going to have a slope of 2, which again means up 2 over 1. Now, notice how I can't go up 2 over 1 because I go off the graph. So instead of going up 2 and right 1, I'm going to go down 2 and left 1, okay? So if you go up and right, it's the same thing as going down and left, okay? So here I go. I'm going to make a bunch of different points. Boom, down and down and down. And then I'll connect them. And I'm going to try to make my line nice and light if I can. Okay. And now what I'm going to do is I'm going to go ahead and erase everywhere where x is not less than negative 2. Okay, so here we go. So I really had that y-intercept as like a reference point to help me graph it, but in the end, that's not going to be included. Now remember, what kind of dot do I put on the end? It's going to be a closed dot, and hopefully you said closed. Good job, because this is an or equal to. Okay, so here's my first piece. And now I'll go ahead and make this a little bit darker. All right, now I'm going to go ahead and move on to my second one, which is the graph of negative 1/2 x plus 4 from negative 2 to 2. Now, this one's going to be interesting. So let's take a look. Now, I've got the graph of 4, okay? And what I'm going to do, now notice, usually, and you know what, to make this interesting, I'm actually going to make this a positive 1/2 x, and I'm going to show you why. So let's try to graph the whole line. So if I graph this whole line, I'm going to start with an intercept of 4, and observe how there is an intersection point here. Okay, here's all the points I can fit on. When I go to make my intersection points, let's see what happens. Oh, see how the lines meet up? Okay, so I'm going to start by erasing everywhere between negative 2 and positive 2, except those rather, okay? So that's all right, because this is less than negative 2. I don't want that. And this is more than positive 2. So I don't want that either, okay? Now on the right, I'm going to make an open dot because this is not or equal to. On the left, now I get this question, Mr. Moray, what kind of dot do I put? In this case, we will leave the dot as closed. And the reason we're going to do that is because this dot is already closed by this piece right here. So if the dot is already closed, you're not going to open it back up. Similarly, if this was an open dot, another piece, like let's say this was just less than, and this was less than or equal to, then this part would fill in the closed dot, okay? So sometimes what's going to happen is the output for the first piece at this cutoff point will be equal to the output of the next piece at the cutoff point, and that's perfectly okay. That happens sometimes, and you just have to make sure in that case your dot would get filled in, okay? All right, now on to my last piece. F of x is equal to negative x when x is greater than or equal to 2. Now in this case, I'm going to cut some corners, right? Now I know that if I keep my negative x going over here, it's not going to be a function. So how about I start my negative x line right here at the intercept, because that's negative x plus 0, and I'm going to go down 1 over 1. The reason I really recommend you graph the entire graph is because sometimes people get confused with what's going on, because what they see is they see the slope and everything starts to get confused. They have the slope, ends up going the wrong way. So that's why I say graph the whole thing. Now I'm going to erase everywhere where x is not greater than 2. In other words, where it's less than 2. And on this final one, I'm going to put a nice closed dot. Okay. Now, I'm going to go ahead and take a second and trace over this because I noted this was kind of hard to see for some people. So how about I trace over this in black, and hopefully that makes it a lot nicer. So I've got this first piece. This is the piece 2x plus 7. It's got a slope of up 2 over 1 and an intercept of eventually 7 when x is less than or equal to negative 2. I have this piece, the graph of 1/2 x plus 4. Remember, we made it into a plus 1/2. And then I have this final piece, negative x, in other words, negative x plus 0 when x is more than 2. So what we have is we have a ray, we have a segment, and we have a ray. And remember, always good to have more rays. Haha. All right. So this is how we graph it. We do one piece at a time. Okay. We graph the whole piece and then erase. Okay. So if you need a second to understand how I did that, go back, rewind through, and then in a moment I'll move on to the next problem. All right. We're going to go ahead and move on down. And what I'm going to do for this one is I'm going to actually do this as like a U try. Okay, so here's my function I want to see on this. Okay, so maybe on a piece of graph paper, and notice how I'm going up by ones. Try to take a second, and if you need to print off a piece of graph paper, go ahead if you don't have one. Try to graph this function. Okay, so I've got f of x equals negative 3x plus 5 when x is less than negative 3. 1/3 x plus 5 when x is less or greater than or equal to negative 3 and less than 3, and x is, or rather, it's equal to negative 1/2 x plus 2 when x is more than 3. So that's negative 3x plus 5, negative 3x minus 5 when x is less than negative 3, 1/3 x plus 5 when x is greater than or equal to negative 3 and less than 3, and negative 2x plus 2 when x is more than 3. As you can tell, it's kind of like a mouthful. So go ahead, take a look at this function. Okay, you'd pause the video, try to graph this, and then unpause and see if you got it right. All right, let's see if we can graph this. So I'm going to blow that off real quick. All right, I'm going to use, remember what we called the May method, and the May method is when I make some nice up and down tick marks here. Okay, I'm going to move that for a second. What do these up and down tick marks do? These up and down tick marks are like little force fields, all right? They tell us where one piece starts and the next piece, one piece ends, I guess you could say, and the next piece begins. So my first graph is negative 3x minus 5. So here's what you should get for your first piece. You should end up getting, so I start at negative 5, I go left 1, up 3, left 1, up 3, left 1, up 3. Okay, start here, and this should be your first piece. So you can see it has a slope of negative 3, and eventually, if we keep going, we'll be back to negative 5, right? We go to negative 1, then we go to negative 2, then we go to negative 5. Second piece is a little something like this. So watch this. This is another tricky one. So this was open, but on my second piece, I've got 1/3 x plus 5. So what that's going to mean is that this dot is going to get filled in because on this cutoff point, that y is the same as this y, okay? That's where it gets tricky. So when you're done erasing, that's what your second piece should look like. It's got an intercept of 5 and a slope of up 1 over 3. And see what I did? I filled in a previous open dot. The reason that is because this included point, its y value was equal to the excluded point, what we had right here. Okay, and last but not least, I've got negative 2x plus 2, and that would have an y-intercept of 2 and a slope of negative 2. So I'd be going down 1, over 1, down 2, over 1, down 2, over 1, down 2. open dot, and like that. Now, on a quiz or a test, for me, it is 100% fine for you to do the up and down dotted lines. If that helps you graph it correctly, that is absolutely okay with me. I care more that you can understand, one, where the pieces start and stop, which pieces do I need, and how do I know what kind of dot goes on the end and the beginning. That matters more to me than, oh, did you do it cleanly without the up and down. As long as you can make it nice and neat, I'm totally cool with these tick marks. And remember, where those came from was I looked at these X values, right? These are the cutoffs. This one stops at -3. This one starts at -3 and ends at 3. And this one picks up. Now remember, if you have endpoints on both ends, this is going to be a line segment, right? Because this tells you where it starts and where it stops. A line segment has a starting and an ending point. A ray has a starting point but no other ending point. Okay? So this would be a ray, this would be a ray, and this would be a line segment. Okay? And remember, filling in a dot is completely okay, provided that you have an or equal to represent the closed dot that's filling it in. So if you need another walkthrough, and I hope you guys got this right, if good, outstanding. Otherwise, go ahead and take another look at this, rewind, and I'm happy to help out with that. All right, last one, and I'll ask you again to try this, and then I'll go ahead and go through it. I'm going to come over to this last one, and here's going to be my function. Okay, so let's see what you can do. So f of x equals 3 when x is less than -2. It equals 1/2 x when x is more than negative or equal to -1/2 or -2 and less than 1. It equals x minus 5 when x is greater than or equal to 1 and less than 3. And it equals 3x minus 8 when x is more than 3. Okay, so take a second, pause the video, see if you can graph this, and then we'll come back and I'll show you how it's done. All right, here's how we're going to do this. So I'll move it off to the side. The f of x doesn't really matter so much as the 3, in other words, the 3, the 1/2 x, the x minus 5, and the 3x minus 8, and the respective domains. So remember, 3, what kind of line is that? Do we see an x? No x, so it's going to be a flat line. It's going to be, y's are going to be equal to 3, and it's going to go until we get to -2. Okay? Then, what kind of dot are we going to leave? We're going to leave an open dot because it's not an or equal. So the value of -2 is not included in that piece. All right, now second one, I'm going to show you the whole graph because you notice that it ends at a 1, and I did that intentionally. So here's what we've got. It's 1/2, so it's got a slope of up 1 over 2, and it's got an intercept of 0, okay? So here's what it would look like if we did the whole thing. Now I'll connect it with a nice light line, okay? And now I'm going to erase. So I'll erase all the way until -2. Notice we're going to put a closed dot on that, and then I'm going to stop it at +1. So erase this all the way to +1. This should be about at 1/1/2, okay? Because up 1 over 2 is the same thing as up 1/2 over 1. And then I'm going to put an open dot on that. And I know these lines are a little bit tough to see, and I'll recap them in just a second. My next piece, and I'll just erase that. My next piece is x minus 5. So it's got an intercept of -5 and a slope of 1. So I start at -5. I go up 1 over 1, up 1 over, stop here. Okay, this is my cutoff, and I go up 1 over 1, up 1 over 1. Let's see, over 1, up 1, over 1, up 1, over 1, up 1, right? So that means, in other words, I should be at, let's see. So here's -3. Here's where I would be. Okay, what kind of dot do I leave? I leave an open dot. Okay? And I connect. Okay, and you can think about graphing the whole line Okay, and now, did I make a mistake? It looks like I did. My bad, folks. Let's just erase this one real quick. Because where should we have started? We should have started at -5. So let's start at -5. And I'll show you, and this is why you graph the whole line. Let's just graph the whole line just to be safe on this one. Uh-oh. I'll just graph the whole piece. This is just the piece we should consider. Now, I'm going to try this again, just for accuracy. So here's where we should be. So that's why I'll make that nice and erased. And then I'll erase on this end. Beautiful. Sometimes you got to give it a nice firm erasing. This is why we do this with a pencil. So I put my closed dot on the 1 and my open dot on the 3. I thought something looked a little bit fishy. And now finally, I'm going to do 3x minus 8 when x is more than 3. So I start at 8, I go up 1 over 3, or rather up 3 over 1, up 3 over 1, up 3 over 1, open dot. And how about, in order to make this work, I'm going to make this an or equal. And here's why. Because I need to make sure every input has an output. So I'm going to go up 3 over 1, up 3 over 1, up 3 over 1, close dot, up 3 over 1, up 3, 1, 2, 3 over 1. Here I go. So this is kind of like a funky little one, huh? A few different pieces to it, okay? All right, so here's what we got. I'm going to go over this in black pen. Let's bring this nice and close. So I've got 3, the constant line, at 3. Uh-oh. That's why we fix it. How about we do it like this? This is 3. See, I got messed up by my little graph. 3. Everyone makes mistakes. Then I do 1/2 from -2 to 1. Then I do x minus 5 from 1 to 3. And then remember, I do 3x minus 8 from 3 all the way on. So just recapping the couple of things I did here. 1, make sure you fix this. I apologize for that. You should have it going at 3, which means it should be a flat line at 3. And I'll make sure that I make a note in the video about that. Make sure you have it stopping at -2. Then make sure you have a graph of 1/2 x, meaning a slope of 1/2, intercept of 0, from -2 is x to 1 is x, with an open dot, closed dot. Then you have x minus 5, so a slope of 1 and an intercept of -5, going from 1 to 3. And then finally, 3x minus 8, starting at 3, going to infinity. Now, piecewise functions are totally difficult, and I think that's evidenced by the fact that even at 30, with years and years of teaching this, I do these videos off the cuff to show you that, look, everyone makes mistakes. This was not easy for me. I got this one a little bit messed up there, but that's okay. All right, we work at it. We use our pencil so we can erase, and you just got to stay persistent. These things aren't easy to do, but what you got to remember is if you keep practicing at it and you keep working at it, this is something you can do. Okay, so I hope you found this video to be educational. I hope it kind of taught you something new. Keep sending me questions, coming after for extra help. And remember, you can do it. All right, keep learning, keep loving math, and have a wonderful day.